So if we look at these laws then, the first one is to do with sine, and if you know the sine graph already, if I've got sine 30 degrees, that will give me an answer. It actually gives me an answer of a half. I'll get the same value, a half, for sine 150 degrees. So whatever the angle is, if I do 180 minus that angle, there'll always be another solution for the same y value. So that was one example there. And where does this come from? Well, in the last chapter, you must have seen the ambiguous case. So sometimes there was two angles when using the sine rule. And to find the other angle, you had to do 180 minus that. So the next one, if we go to the cos rule then, so we've got a cos graph here, similar to the sine one, but rather than doing 180 minus the angle, you do 360 minus the angle. So say you've got cos of 30 degrees. Now cos of 30 degrees is root 3 over 2. So that would be root 3 over 2 there. If I do 360 minus 30 degrees, I get 330. So 330, or cos 330, would give me the same answer, root 3 over 2. If I go to looking at how often cos, sine and tan repeat, cos and sine repeat every 360, so you're going to get more solutions after 360 degrees. And tan repeats every 180, so again there'll be more solutions after 180 degrees. The way we can find more solutions is by, let's looking at the sine graph here. Above we saw that sine 30 is a half, sine 150 is a half, but if I add 30 degrees on to 360, I get 390. So 390 would also produce the same solution of a half. I could add on 360 to 150 degrees and that would produce the same answer of a half. So very similar with the cos graph, I can keep adding on 360, and with the tan graph I'll just change it to 180. For the last rule, it's what I was talking about from the tables, so the exact values, and we saw a link between the angle relating to sine and the angle relating to cos and how they added up to 90 degrees. If they added up to 90 degrees, we got the same answer. So if I just go back, these ones that I was dotting, we got the same answer when the angles added up to 90 degrees. So if you have sine of any angle, it's the same as cos of 90 minus that angle. So an examples there, sine 50 degrees and cos 40 degrees would be the same answer. Why does that work? Well, from the previous chapter you were introduced to cosine, so the cosine rule. The longhand way of saying that is complementary sine. So you're doing the complementary angle of sine. Okay, so just exploring this in more detail then, we're going to be using the rules that we've just seen, the graphs, and also the exact values in the table to help us answer this question. So I'll just read it now. It says express the following as trigonometric ratios of 30 degrees, 45 degrees and 60 degrees, and hence find their exact values. So I've got to get these in terms of those angles first, because then I can use the table for 30 degrees, 45 degrees and 60 degrees. So this is the case where I'm not using my calculator to practice again. So tan 225 degrees, something I know about tan is that it repeats every 180. So if I take off 180 from 225, I get tan of 45 degrees. And from the table, have that in front of you, tan 45 degrees is 1. So I've answered that one. If I do the same for the second one and take 180 degrees, because I've still got tan, I'll have tan of 30 degrees, which is 1 over root 3. The next one is sine, so I'm thinking about some of the rules I've seen with sine. The first rule we saw, where if we do 180 minus the angle, we get another angle. So if I do 180 minus 150, I get sine 30. And sine 30 is a half. So notice how I'm trying to get 45, 30 or 60 degrees. If I go to the next one, cos 300 degrees, I could use the second rule and do 360 minus this angle to get another angle. So cos 300 is the same as cos 60 degrees. And I know that cos 60 degrees is a half also. Now, sine of minus 45 degrees, if I do the 180 minus the angle, I'll actually be doing 180 add the 45 degrees, which will produce 225 degrees. That's not going to help. I need it in terms of 30, 60 or 45. So if the rules aren't going to help, then I might have to go to the graphs. So let's have a look at the sine graph in more detail. I've got sine of minus 45 degrees, so in between minus 30 and 60, somewhere there. Now, how could I get it in terms of 30, 45 or 60? Well, due to how the graph is, if I look at the positive 45 degree angle there, whatever that value is, they're the same, but one's the negative of the other. So that must mean then that sine of minus 45 degrees is equal to minus sine of 45 degrees. So whatever sine 45 degrees, the negative of it. Well, then I've got it in terms of 45 degrees. So this one I can write as that. Now I know what 45 degrees is. Sine of 45 is is 1 over root 2, sorry, but I need minus 1 over root 2. If I go to the next one, cos 750 degrees, I'm thinking about the graph repeating every 360. Now, if I take one 360 off, I'm not going to get to an angle of 30, 45 or 60. But if I take two 360 degrees off, then I will have enough because I'll take off 720 degrees. So two 360s is 720. If I take that off, I get cos of 30 degrees. And I know that cos of 30 degrees is root 3 over 2. If I do the last one, cos 120 degrees, I know that I could find another angle by doing 360 minus 120, but I'm not going to get one of the angles I need. So I think I'm going to use the graph again. So cos 120 degrees is here. And I'm going to then find something linking to 30, 45 or 60. So I probably will need to go to those angles up here. And if I'm looking at where I am, 60 degrees is going to come out with the same value as 120 degrees. Okay, the same value but positive and negative again. So I'm just looking at sort of how the graph is, some symmetry relating to the graph. So I think I can do something similar to the sine one before. If I've got cos 120 degrees, it can be the same as minus cos of 60 degrees. Okay, they're both going to produce the same answer. If we look at this properly just to check, it was right on the line here, so I could probably tell you what y value that is. It's not minus 0.1 or 2, 3, 4, 5, minus 0.5. Cos 60 from the table, we know is a half. You can tell from here 0.1, 2, 3, 4, 0.5. Okay, so if I say that cos 120 is the negative of cos 60, it looks right to me. So last one, that's the same as minus cos 60 degrees, which is minus a half. Okay, so now I'm going to introduce you to something called the cast diagram. And what essentially is going to be happening soon, and probably in the next video, is that we're going to start solving equations with trig in them. So sine, cos or tan involved in equations. Now we can use all the things we've just been looking at. So these rules here, exact values if needed, the graphs, you can actually solve equations from the graphs, and I will be showing you that as well. But a cast diagram is the most efficient method we've found going forward for the trig questions you have in year 1 all the way through to the trig questions you have in year 2. And cast actually comes from the concepts of the unit circle and the graphs linking to the unit circle. So I'm just going to explain cast. So the cast diagram is used to summarise the quadrants from minus 360 to 360 degrees. So if you think about the graphs, that is from 0 to 360 degrees and all the way from 0 to minus 360 degrees. In particular, we're looking at where the three functions, so sine, cos and tan, are positive in those quadrants. So we've already seen that we calculate positive angles by reading off the diagram from the positive x-axis in an anti-clockwise direction. So I would take this angle round in an anti-clockwise direction to read positive angles, and you always start from this side here for the positive x-axis. But I can also get negative angles by going clockwise from the positive x-axis, so all the way around like that. Okay, so anti-clockwise for positive angles, clockwise for negative angles. And the word cast comes from this below, C-A-S-T. So cos is in the fourth quadrant, all is in the first quadrant, sine is in the second quadrant, and tan is in the third quadrant. So C-A-S-T. And I'm going to explain why it's labelled the way it is now. So going back to the graph, so remembering the unit circle, we would start and drag this around, and you would see how the graphs are formed from dragging the point around the unit circle. Now, if we look between 0 degrees, so when there's no angle, to 90 degrees, when you've got an angle of 90, so that would be 90 degrees there. Let's see what's happening with the graphs. So between 0 and 90 for sine, we've got this part of the graph here. Between 0 and 90 for cos, you've got this part of the graph. And then for tan, between 0 and 90, you've got that part of the graph. Now, all those parts of the graph are above the x-axis, and the y value is positive for all those parts. So between 0 and 90 degrees, all graphs are positive. They have a positive y value. If I go from 90 to 180 degrees, so this time, rather than having an acute angle for the first quadrant, they were acute angles. I'm going to go to the second quadrant where we've got obtuse angles between 90 and 180. Let's see what's happening with those parts of the graphs. So between 90 and 180 for sine, it's positive. Between 90 and 180 for cos, it's negative. It's now underneath the x-axis. And then for tan, between 90 and 180, it's negative. So the only graph that is positive between 90 and 180 is the sine graph. So I'll put sine here. Now if I go beyond 180 degrees, I will have another 90 degrees added on, which is 270 degrees. And this is where we're getting into the reflex angles. So past 180 is a reflex angle. So the third quadrant is reflex angles, and also the fourth quadrant will have reflex angles as well, because you'll go all the way back to 360 degrees. So if we look at the graph in those parts then, between 180 and 270 for sine, we've got negative, it's negative there. Between 180 and 270 for cos, it's negative. And for tan, between 180 and 270, it's positive. So the only part or graph which is positive between 180 and 270 is tan. If I do the final quadrant between 270 and 360, sine is negative, cos is positive, and tan is negative. So the only graph which is positive between 270 and 360 is cos. So this is where the words come from. This is why it's called a cast diagram. So it's really important to know what these represent. So all means that all graphs, sine, cos and tan, are positive between 0 and 90. 90 and 180 is only sine that is positive. 180 and 270 tan is only positive, and 270 and 360 cos is only positive. And you can see that from what I was doing with the graphs. So in the next video, I'm going to be showing you how all this ties together then. So where we're actually solving something like sine x equals 0.6. I want to find angles for x which produce a y value of 0.6.